Hey guys, let's talk about what happens to make the largest weather system on the planet. Let's just draw the very top of the globe here. Drawing the 60-degree line. Okay, now something special is going on at the 60-degree line. Air is coming up from where it descends down here on the 30-degree line. All right, we had air from the equator that had risen up and had come down to the ground here, and it spreads out. Some goes back to the equator, some comes up here. We also have cold air coming down from the poles, and that makes the air rise here. So right along the 60-degree line, we have air rising here. That makes it a low pressure, and that means the wind is going to be coming down from the poles and curving to the right, just the way it does in the northern hemisphere. And notice that that would be, in fact, a right curve. Below the 60-degree line, air is coming up from the high-pressure system generated by all the air sinking at the 30-degree line, the 30 degrees north. So the air from the high pressure going up to low pressure also curves to the right. That means we have air basically going this way, north of the 60-degree line, and this way, south of the 60-degree line. Well, anytime you have two fluids moving past each other, we would call this shear. Now, scissors are a pair of shears, right? They have two blades moving in opposite directions. Here we have wind shear. Anytime you ever saw wind go across water, well, the water wasn't moving the same speed as the wind, moving two different speeds. What happens? You get waves. That's what we get. We have waves along the polar front. These waves are called Rossby waves, and they move in that direction. What we want to look at is one section of the Rossby waves where we'll take a look at what's really happening here. We have cold air coming down. This would be cold air from up north. South of that, we would have warm air moving up. Okay, so what's going to happen here? If we have warm air moving up, warm air, less dense, slides on top, all up and down here, condensation. Cold air sliding underneath the warm air pulls on top of that, all here. We also have condensation. So this whole area is filled with a lot of water vapor condensing, releasing heat energy to the atmosphere. Here we go. Heat energy to the atmosphere makes the air rise, and it makes a low pressure system. Let's take a look at what one of these things does when it gets going. As soon as it gets this condensation happening and all this heat being released, it gets pretty warm. The air rises and starts pulling more air in behind it, which causes more condensation, which causes the air to rise, which pulls in more air behind it, which causes more condensation, which causes more air to rise. You can see the whole thing kind of gets out of hand here. Let's see what happens next. Well, if we look at a typical one of these waves, you're going to have a couple things. You're going to have cold air sweeping in here and making a cold front. Awesome. Out in front of it, you're going to have warm air sweeping up to the north. And that's going to make a warm front. So here's the center of the low right here. And we know air circulates counterclockwise and in around a low pressure system. So all this air is going to be circulating counterclockwise and in around this low. The condensation field here is going to be in this area. The condensation here is going to be in this area. So you have the heat being basically released there. You have a warm front, cold front. This is known as the warm sector because it's basically, for us anyway, pulling air up from the south. For us, very often, it's pulling air up directly from the Gulf of Mexico. Warm and humid sector. That makes our storms extra special. You have the warm front air. Okay, so you have long period of increasing clouds and eventually a day or so of wet weather, at least a good period of wet weather. It clears and you get nice warm day, and then what shows up? All of a sudden a line of thunderstorms, and that line of thunderstorms will come right through. Now, if we think about a cold front, the air's barreling along the ground, very efficiently moves hot air out of the way. If we think about a cold front, or warm front rather, the warm front slides up over air. It does not push the warm air, push it very well. This is relatively cool air up here, and the warm air is trying to slide that out, but it has to do it like on a wedge thing. It's wedging it out, not going to work very well. So this front is slow, this front is fast. Well, you can see this shape is going to change then. If this is slow and this is fast, what's the next thing that's going to happen? Ooh, let's see. Well, the next thing that's going to happen, the cold front is going to start to overtake the warm front. We're going to say it zippers up. So here, right here, the cold front already has caught the warm front. We have a special symbol for this. It's the cold front symbol along with the warm front symbol next to each other. This is a new kind of situation we call an occluded front. All right? And right here, the warm front has caught the cold front and lifted it off the ground. That's going to look, if we have a cross-sectional view, you have the warm front going out like that. This is the warm air lifting up like this. This is relatively cool. And here comes barreling along the cold front. Well, the cold front catches the warm front and lifts it right off the ground. So the actual front ends up being like this. This is the cold air, this is the cooler air, and all of a sudden now you have a situation in an occlusion where the warm air is all aloft. Well, now where's it going to get its heat and its humidity from? It's not. This is why the storm will eventually die. So as it zippers up, it also dies. This storm, if you look at some pictures, these storms are continent-sized storms. These are much, much bigger than hurricanes. A hurricane, by comparison, would be on the order of that compared to a storm like this. This storm, once it gets going, is called a mid-latitude low. Why is it called a mid-latitude low? Well, let me finish drawing in the fronts here. Here is the cold front, still zipping up behind. Here is the warm front, out in front. The warm sector getting increasingly narrow. But let's take a look back and see why it's called a mid-latitude low. If we look at our Earth diagram, these Rossby waves happen on the 60-degree line. All the energy for the mid-latitude low is coming from the warm, humid air in the mid-latitudes. So these really don't do anything north of the 60-degree line. They break off and they wander down into this area. What is this? This is the mid-latitudes. And these huge storms bring us most of the rain and precipitation we get. Down here in the tropics, most of the rain you get are thunderstorms, standard thunderstorms throughout the day. But for mid-latitudes, we get the biggest storms on Earth, and aren't we lucky? Well, what's going to happen here? Let's just go to the next one. The next one, you could probably guess what's going to happen. This cold front is now catching up and really zipping up the warm front here. So look at that. We have that cold front symbol merged with the warm front symbol. Again, meaning this front is occluded. And we have then the warm front and the pure cold front. And you can see this process will continue. This will zipper up and kill the entire storm. The storm will linger out and eventually die. You can see that the warm sector is getting progressively smaller and smaller. But this is still the center of the low, big center of the low. Ooh. And the air is still sweeping into the low, counterclockwise and in like usual. So this storm will usually persist not much more than 2 weeks. It'll move halfway around the world very often, maybe further. It'll span whole continents and it will control our weather. The mean weather will be along the cold front. That's where you can have tornadoes, hail, big thunderstorms and such like that. The warm front is that warm, gentle rain we're used to. And the warm sector is a nice day for getting out and playing. But imagine all the folks here. What kind of weather do they see? Well, let's look at the cross-section again. Right? So what they're seeing, to begin with, they're seeing this nice warm front. Right? You can see everything starting. Those cirrus clouds. And then the cirrostratus, altostratus, stratus. Hey, you know a warm front is coming and it's going to be like warmer and more pleasant. And all of a sudden, hey, what the heck? There's thunder and lightning outside because, nope, it's not a warm front, really. It's a warm front with a cold front catching up and lifting the whole warm air off the ground. You get then big thunderstorms in those cumulonimbus. And those cumulonimbus clouds will put a little lightning bolt there. Those cumulonimbus clouds will then be followed pretty quickly by a cold air mass. And that then, it will be the end of your mid-latitude low. It will have passed. What's the weather like after a mid-latitude low? Well, let's think about that for a second. What kind of air is coming in here? Where's this arrow coming from? Ah, for us, it's coming from no, it's not coming from there. It's coming from Canada. And from Canada, what kind of air do we have? What kind of air masses in Canada? Well, easily enough, Canada, continental. Is it polar or tropical? You got it. Continental polar air mass. What's a continental polar air mass like? Dry and cool. If it's in the wintertime, okay, it might be dry and cold. But what's the weather going to be like in there? Well, it's going to be clear until the next storm comes through. The next time a storm comes through, you bet, it'll be a mid-latitude low. It'll start, generally speaking, with a warm front. And the warm front weather, you might be lucky enough to be in the mid-section of it, the warm sector. After that, you're in for some thunderstorms. After that, some dry, cool air. Notice that's the weather pattern that we see most of the time in our country. Well, thanks for listening to this episode of Yo at Home.